So today, ang present ko is Spot and Learn, maximum entropy patch sampler for few-shot image classification. And fun fact, these guys are from NTU in collaboration with CMU. Yeah. So what is their idea? Basically, their idea is having an attention mechanism added to the few-shot learning pipeline, wherein the attention has variety. So for example, yung nakuha niyang patches of images is not constant, but different patches of the image of the object being detected. And their justification for this is that, so kasi if one of the issues of the attention mechanisms that doesn't have variety or only has attention in specific parts is that it may overfit, or sometimes kasi hindi niya nakaka-capture yung object being detected, so that may cause some issues when it comes to detection. So contributions. So I also think that their major contribution is the use of deep reinforcement learning for few shot learning, which is kind of new. So I think they're the first one to do it explicitly. And then, ayun nga, during training, iba-iba yung nakuhang patches of images for attention. And yung proposed sampling mechanism also uses positive and negative sampling policies to determine the patches of interest or patches na nakikita yung object being detected and the background. And of course, maganda yung results daw nila against previous works. So just some backgrounds for reinforcement learning. Uh, so what they did is that they have a sequence of actions which is defined as patches of images from the input image, and the actions aim to maximize the rewards. In this case is R of n or R of t. So the value of it is 1 pagka na classify siya correctly during that time step, or 0 pagka hindi siya na classify correctly during that time step. So parang yung patches na yon pinapakita na kung tama yung kung kailangan maglagay ng attention doon, ibig sabihin kasi naka-classify yung images with those patches. And they also have a constant which is less than or equal to 1. I'm not really sure what the discount factor does exactly. And nakuha yung patches of images using the function policy pi. So policy pi is defined as the action given a state, where a state is like having other contexts like in global context and stuff like that, parameterized by theta. And the policy pi can also be done by a neural network, and this is based on the policy gradient and Q-learning methods. However, the issues with these is that they can they can have collapse to just a single mode. So it's just the locations near the peak. Ang problem with this is that I think yung sinabi nila, pagka ganito kasi it may overfit, and the and if you use it on like few shot learning, hindi siya mabilis mag-adapt kasi onti lang yung onti lang yung samples mo. So what they do is that to increase the variety so that you have different places as to where to get those patches of images. They have maximum entropy reinforcement learning. I'm not really sure how it works on the inside, but it basically, dun sa objective function nila, nagdagdag sila ng isa pang term that adds variety to the actions or the patches of images na nakuha while still obtaining a high reward or still classifying the object correctly with those patches of images. So, yeah. So this is the one of their contributions, yung pag-add ng variety sa attention or the patches of images needed to detect the object. Now this is their pipeline. First, they have a the input image ipapasok nila sa maximum entropy sampler. So the maximum entropy sampler is just there to generate patch varying patch trajectories from the input image, and gumagamit siya ng ng maximum entropy sampler to sample the next candidate patch image, so for the next time step. And then yung input niya other than yung input image is the previous patch image obtained from the state encoder, and then it also outputs. So yun nga, also has two functions. Meron siyang f of q. This is to get the q value, which is needed to get the patch, what patch, and then the policy pi parameterized by theta. And the output of policy pi is the action, which is the coordinate of the patch image to be used, and then yung embeddings for the different layers of the input image. And then we have the state encoder. Uh, the state encoder is used to aggregate the features of prior extracted patches for the input image, and it's a recurrent neural network. Yun nga, para magkaroon siya ng some sort of memory to encode the state S yun nga, from the previous states, and the sample patch image, yun kukunin niya as input yung previous state plus yung sample patch image that is inputted to the action context encoder. So yung action context encoder naman is it takes the output nga of the policy pi function together with the patch image. So intuitively speaking, the action context encoder aims to account for the global information produced by the function policy pi, which is utilized for the state encoder. And then you have your feature extractor. The feature extractor only extract features from the patches and not the entire input image. And the output of these feature extractors are also inputted to the state encoder. So this is nga yung katulad ng sinabi ko kanina, the state is needed to obtain the next patch image na kukunin mo. And then after that, yung output ng state encoder for that current time step can be used as input sa classifier mo. So first, you're going to transform it to vector L. You're going to encode it to vector L which is then inputted to a softmax so that you can classify what label that ano yung label ng image ng input image na yun with just that patch of image. And then of course, backpropagation. So yun yung 5 parts of the pipeline. Maximum entropy sampler to get the patch image, state encoder. This is to get this to aggregate the information from the patch image, the features from the patches and the prior patches. I the features of the patches and the action context encoder. And also, since RNN, nakuha niya rin, meron rin siyang information from the previous state. And then, of course, action context encoder to get global context from the patch image and the input image. Feature extractor for the patches of the images. And the classifier, of course, to classify the image. So, other than just that part of the pipeline, they also have a sampling mechanism that uses negative sampling to identify the background and the foreground or the object being detected. So as seen here sa graph, kasi if you just use the normal sampling mechanism, which is basically the normal sampling or like attention mechanism, kinukuha niya lang yung peak, yung kung saan nagpi-peak yung performance or something like that, wherein it may not necessarily be on the image itself. Nagpipeak yung score, sorry. Ay nga, basically kung saan nagpipeak yung score, saan nagpipeak yung, basically saan gumaganda yung results. And sometimes, nakuha niya yung background, which is something you wouldn't like. So, ang ginawa nila is they used negative sampling so that yung mga background parts will be filtered from the parts that are actually part of the foreground. So this is simply adding another condition. So it's just adding a negative condition and a positive condition uh, so that yung background ma-identify from the foreground so that you wouldn't use the background on as the patches used for classification. So this is so for example, like yung common example na yung hindi daw nila ma-detect yung husky kasi madalas ay nadedetect nila yung husky as a wolf because it's always on snow. So ang nangyaring basis pala ng classifier is yung snow rather than the dog. So it's something like that. That's what they're trying to avoid, yung ganong klaseng overfitting. So this is their training algorithm. And then just some results. Of course, they use two methods of classification. One is the use of fully connected classification, so softmax, and the other one is cosine similarity. So this is just distance measurement rather than softmax. And then sa omniglot, they had better performance but medyo madali na talaga yung omniglot. So, but they had better performance with cosine similarity. Sa ImageNet, on the other hand, they had better results on one shot. But nung 5 shot, talo pa rin siya na prototypical. Yung sharp meant that yung training niya is like 20-way or 10-way, if I recall correctly. And then however, meron silang nakasabay na this 2019 na mas mataas sa kanila yung one shot. But yeah, I guess they have other contributions pa rin naman, like yung sa reinforcement learning and then a different way of having the sort of attention, yung variety attention. Ayun, they also had like Q soft and Q hard. I wasn't very clear on these things. Medyo nalito ako sa kanya. Uh, so basically kasi yung sa soft, uh, you classify, yun yung may variety. And then hard, if I recall, I think yun yung walang variety na Q-learning. So, ayun lang, they're just showing na mas maganda yung results ng soft. Mas robust. And then results on their sampling trajectory. Uh, ito yung baseline and then yung novel. mm, I guess it's good-ish. They still sometimes get patches of some of the background that barely has any of the object itself. But generally, nakukuha naman yung patches that are actually part of the object, and which is good for classification. And mas na-avoid niya yung random stuff lang yung nakuha niyang patches. So, ito lang yung results niya. Dun sa writing, wala akong nalagay because honestly, I didn't like the writing that much. Maybe because of certain reasons. I mean, for example, I read something like I guess it's a bit generic. Wala siyang impact masyado. And yung katulad ng sinabi ni Stan dati na na Asians are trying to be complicated. Just for example na lang yung dito sa nila, yung pipeline nila is very convoluted a bit. I get at least yung presentation niya and how they explain it, how they want to show it, makes it look very complicated. But I think there is better or simpler ways to visualize their pipeline, and also simpler ways to explain their idea, I think. Because they're trying to like put complexity doon sa idea nila just to show. I'm not saying that they're showing off, pero yeah, they're trying to make it complex nga, which is, to me, is unappealing. So, ano pa ba? Yeah, yun yung a bit of feedback ko sa kanya. However, I can't really say a lot because medyo pangat nga yung background ko sa reinforcement learning. I just accepted what they said about it. Yun, yeah, that's all. Thank you.